Hello, we're going to take a look at Chapter 12, Objective 4. Now, with Chapter 12, Objective 4, I am splitting this into a couple videos just because it is lengthy. We're going to look at the type of channel proteins that are found in the nervous system. So this is something that we discussed back in Chapter 3 over the biology chapter, but we're going to really get into some detail here with these channel proteins because we're going to need to put them into use in the next objective. So objective 5 and 6 in this chapter is when we're going to actually put those channel proteins to use. So before we get into the channel proteins, let's just kind of take a look at what's going on with the neuron. So what does it look like when it's at rest? So you've got this handout here. It says Chapter 12, Objective 4, Characteristics of a Neuron at Rest. So this is, well, a neuron that I drew, so I apologize for its weirdness there, but it'll just have to do for what we're doing. I do want to go ahead and let you all know I am color coding the rest of this unit. So every time we need to use sodium, sodium is going to be green. I'm just going to put a little key up here. So sodium, from here on out, we're going to represent sodium as green. We're going to represent potassium as purple. And we're going to represent calcium as blue. So that's kind of our color code there. Sorry, the purple and the blue might look a little too close together there. Let me see if I can maybe get a different blue. Yeah, that one maybe looks a little bit better. Either way, we're going to use calcium for being blue. So now that we kind of have our color code, I'm going to do that, like I said, for the rest of the Chapter 12. So let's take a look at what a neuron at rest is going to look like. So we have to understand what it looks like when it's not doing anything. So when it is doing something, we can see what's happening. So we need to kind of have a baseline, so to speak. Let's just kind of take a look at some of the parts here. I'm just going to use a generic color here for this. So hopefully you all recognize that this is a neuron. These structures here, these are your dendrites. This is the cell body. We've got our axon, which kind of goes from here to here, let's say. So that's our axon. I don't want to write too much in the space. And then we've got our axon terminal. So just a quick review over some of the major components that make up the neuron. So now let's take a look at where we have our ions. You're just going to have to memorize this, okay? There's just no other way about it. So this is outside the cell. I'll go ahead and put this as extracellular. And this is intracellular. Okay, so we've got inside and outside the cell. So outside the cell, we're going to have a high concentration of sodium ions. And I'm just going to represent that with a little up arrow to let you know, hey, we've got a high concentration of sodium ions that are outside the cell. Now, that's not to say we don't have any sodium inside the cell. We do. It's just that we have higher concentration of sodium on the outside. The other thing that you're going to need to know is where potassium is located. Potassium is located in high concentration inside the cell, and we're going to really be looking at that axon there. So that's where we're going to put our high concentration of potassium. I'm going to go ahead and let you know where we have a high concentration of calcium. Now, when we get to the calcium, we're going to really be talking about calcium at the synapse, or in this area over here. So I'm going to just kind of put calcium in high concentration, kind of over here. This is the last time we're going to talk about calcium for a while. We'll talk more about that in Objective 8, but calcium is also going to be located in high concentration outside the cell. So another component, another thing that we're going to take a look at is this right here, and I'm just going to be really looking at the axon part. You know, this is the plasma membrane here. So the plasma membrane, if you remember, is a phospholipid bilayer. And it's really separating the inside of the cell from the outside of the cell, and it is controlling what goes into and out of the cell. So if you remember back from when we talked about organelles and we talked about the cell, that's where we talked about the plasma membrane. So if you need to, take a look, go back and review that. Now, this plasma membrane is also known, because we're talking about the plasma membrane of the axon, sometimes this is called the axolemma. So if you ever hear that, that's all that's talking about. It's just a fancy name for the plasma membrane of an axon. Another thing that you're going to need to know is the charge of the cell. Yes, the cell has a charge associated with it. We'll talk about why the cell is charged as we move through, but for now, we're just going to talk about, hey, this is the charge of the cell. It just so happens that the inside of the cell is going to carry a negative charge. So I'm just going to put a little negative sign on the inside of this plasma membrane here. And the outside of the cell is going to have a positive charge. Now this is just on the very, very outside of the plasma membrane and just the very, very inside of the plasma membrane. So there's a net negative charge on the inside and a net positive charge on the outside. And if you look, the charge difference across that plasma membrane, if you think about it, kind of is like a battery. So it's going to allow a current to flow, and because you've got a difference in charge here. The actual difference in charge is going to be taken from the respect of the inside of the cell. So we're really looking at what is the charge on the inside of the cell going to be, and it is going to be minus 70 millivolts. This is the membrane potential. And when the cell is at rest, it is sitting at minus 70 millivolts. So it has a charge associated with it. If you take a look at like a battery and you look at AAA battery or something like that, you can see that on one side of the battery, it's got a negative charge. On the other side of the battery, it has a positive charge. And if you look at the charge on the battery, it's 1.5 volts. Well, this is very similar. The charge on the inside of the cell compared to the outside is minus 70 millivolts. And we're going to call that the membrane potential. And as long as there's a charge difference, you're going to have a charge going through that cell. So yeah, we like having the charge difference. We will talk about what maintains that charge difference a little bit later on. So for now, you really just need to memorize the parts of the neuron, these major parts of the neuron here, and the charges. Sorry, I'm dragging this back over here. In your notes that you've got in your PowerPoint, I do have the blank page here, and then I have just the summary of what we just mentioned, and then I also have a uploaded picture of what that drawing is going to look like. So in case you weren't able to draw it with me, this is what the result is, and this is also on your Moodle page as well. So let's go ahead and take a look at these questions over what we just did. I'll give you a second to take a look at those. Okay, so when the neuron is at rest, and these are in your in-class questions that you have in your packet that you got from the bookstore. When a neuron is at rest, the sodium ions are in high concentration, and you should say outside the cell, so that would be B. Number 2, when a neuron is at rest, the membrane potential of the cell is minus 70 millivolts. And then number 3, when a neuron is at rest, the inside of the cell is negative relative to the outside. So why again is that a negative 70 millivolts? Just to kind of show you where that negative sign comes from. And again, it's really not too big of an issue here, but why negative and why not positive? Because again, we're looking at the charge on the inside of the cell, and if you notice the inside of the cell is negative, that's why that is negatively charged. It's coming because the inside of the cell is negatively charged. That's what that negative sign is. If the inside of the cell was positively charged, well, there would be a plus sign in front of that. So all that's doing is telling you what the charge on the inside of the cell is. So that's just going to help you memorize that. And that's going to conclude this part of Objective 4, and we will come back and take a look at the channel proteins in Objective 4 in the next video.